Well, one of the most visible consequences of a warming world is the increase in the intensity and frequency of extreme weather events.
The number of heat waves, floods, and wildfires have increased across the country. Steve Vavris is a senior scientist at the Nelson Institute Center for Climatic Research and an expert on extreme weather and climate change.
Welcome.
Nice to see you. Welcome to Live at 4.
Thank you. Happy to be here.
So it has been an extreme summer. We're looking at what happened in the Pacific Northwest earlier this summer in June, and records have been shattered all over. What is happening? Is this climate change, or don't we know?
Well, there's definitely a fingerprint of climate change on this, near record highs, record flooding, and so forth. And this is not just a blip. It's important to realize this is not just one summer. It's not just 1 month. This has been a long-term trend over several decades. We've seen across the Northern Hemisphere increases in extreme heat and also increases in these intense rainfalls.
And it's all over the globe. It's Europe, it's China, it's the U.S. It's not isolated to the United States.
Absolutely, and that's what gives climatologists more confidence that this is not just a fluke, it's not just a regional occurrence. It really does. The more places it happens more consistently over the years, the more we can feel comfortable attributing at least most of it to climate change.
Has this summer been unusually abnormal?
Well, it seems like things are getting more normally abnormal, to be honest. It's getting to the point where every year is a record or near record year of global heat. And with that comes these consequences of rising temperatures when it comes to the extreme heat waves. A warmer atmosphere can hold more moisture. And so when weather conditions are favorable for heavy rainfalls, we tend to get more rainfall. And so it's all kind of playing out according to what we expected.
And it seems like storms move more slowly than they used to.
Well, that's an interesting point, and that's considered a likely consequence of climate change, in part because the speed of the jet stream winds depends on the temperature difference between the Arctic and the tropics. And as the Arctic warms faster than anywhere on the planet, that reduces that temperature difference and slows the jet stream winds. And so one of the consequences of climate change may well be a more stagnant circulation. And so when we get these intense weather events, they have a tendency to stick around longer.
You've been researching this for a very long time. What do you think the future will hold? Do you expect this kind of trend to continue?
Absolutely. What we've been seeing so far is really a harbinger of the patterns that we expect to come. Climate models for a long time have been insistent that as the climate warms, the atmosphere can hold more moisture. That moisture can be wrung out more effectively during flooding events, for example, and that the Arctic should warm faster than anywhere else on the planet. And we've been seeing that play out too. So there's been very few instances in which the climate model forecasts have been really different from reality.
Is it too late? Can we turn it around?
Well, I think if we think in binary terms, it's too late. There will be continued human-induced climate change, but it's in our power to decide how much. So I think of it more as a spectrum that we can avert much of the worst consequences by taking action now and slowing the climate change that will take place, and then trying to avoid the worst, most extreme scenarios that could happen.
All right. Steve, thanks for being with us today. Very interesting and disturbing at the same time.
We will have you back. Great to see you.
Thank you.